Hello guys, welcome to my YouTube channel, and today I'm gonna show you about my face mask classification model by using PyTorch framework and by using OpenCV library and by using MTCNN model. For this project, I use my custom dataset, and I also download another dataset and I make it unique by combining them. During making my own dataset, I use the MTCNN model to crop to detect my face, and after it detects, I cropped it and saved it and make my own dataset. And now I'm gonna share with you. My dataset folder is contains another 3 folder. First one is for testing, second is called train, third is val. That means third is for validation, second is for training, and first is for testing. And now I'm gonna enter train folder. Train folder contains another 2 folder that's called 0 and 1. If you go 0, there is images of the person without mask. We will explore now. And if you go to another folder called 1, there is image of the person with mask. Totally, my dataset contains 100 images of the person with a mask and another 100 images of the person without mask. Now let's go our Jupyter file. Let's go into my codes and modules, and we'll use it in the below section. And then I write a code to change the device. For example, if our device has a GPU, which is CUDA, it will change our device to GPU. Otherwise, it will stay as a CPU, because if you work on a GPU format, our model work faster and it will save our time and it will be more efficient, because GPU works parallel and it will calculate matrices parallel that helps us to save our time. And now I'm gonna move to my face mask dataset for training, validation as test data. This dataset this is all about getting the images from folder and resizing it and making it ready to use. First, I initialize the image path labels by using def.init, and for this I just write self.imagePath equal to image path and self.labels is equal to labels. What we enter now, enter will get this, and I create a def len to get the length of our image path. And after that I create get item function. This will help us to get the image from the specific address, also to get the labels of the image from specific address, and use the IDX here to get the index of our image path and label path. And after this, by using the OpenCV library, we we call the function called ImageRead, and it will read our image path. And after this, we convert this image from BGR to RGB, because in normal OpenCV the image can read as a BGR, but in our normal laptop, in normal cases, our image will be in RGB format. That means if you talk about BGR, it will be like blue, green, and red. But in RGB, it would be like red, green, blue. Just order is different, but it also play the important role to change our image type from BGR to RGB in order to get the result that we want. And after this, I write a code. I call the function called resize from open. I called import. I call this function by using cv2.resize. I put the image and I just resize it and make the height and width to 124. And after that, I write a function I write a code to apply the transformations for our image. And finally, this class will return our image and with label. For example, there are two types of image: the person with mask and person without mask. And next image is face mask detector that will detect whether the image contains face mask or the person don't wear a mask. It will give information about that. And for first, on this class, we initialized our model, and we just if we have a GPU on our device, it will move to GPU. Otherwise, it will work on CPU. We just initialize this to self.device variable, and after that we create a self.model to load our model by accessing the model path, and we change it to device, which means to change it to GPU if you have GPU access, otherwise it will remain in a CPU. And after that we write like self.transform and transforms.compose, which apply the many things to our image, like transforms.pil image that will change our image to pile image, like pillow image format, and after that it will resize, and finally it will change to tensor and normalize, which means it will change to tensor matrices and normalize the matrices. The next code is all about loading our model, and what I'm talking about by this. For this model, we use a pre-trained model like ResNet 15, and we call it from our PyTorch. And for this, we write the code like nn.linear num-features 2. That means from our deep learning model, we'll get two output. First for the output, one will return us 0, one will return us 1. That means one is returned the persons with mask, one is returned where the person is without mask. And we'll load our model and model.eval, and it will return our model. And after that, we create another function inside our class called detect. In this one, we create a variable frame, and after after image is transformed, make a transformation on the above, it will unsqueeze. That means it will add a batch to our image, and to self device is moved to GPU if you have GPU on our device, otherwise CPU. And I write the code torch dot no grade. In order to in order to avoid crashing, for example, if you run the second times, if you don't write this code, our weights of our neural network model will change and may have some crash, and this code will avoid this kind of crash. And we create a variable called output, and that would be like this frame, this image will be inside the self.model. That means this kind of our image inside our model, to this image many functions will be applied, and we will get probabilities whether this image is with mask or no mask. And to get the probabilities, we use softmax function in output. Softmax is one of the activation function that we use when we train neural networks. And actually softmax works for classification problems, and it will work in a output layer. And this my code mask probability, and probability is one.item. That means like if our deep learning model and a neural network returns 1, that would be like mask probability, the people who has a mask. And the no mask probability is if our deep learning model returns 0, that means that the person don't has a mask. And we label it like we're writing this code. If the mask probability is greater than no mask probability, it will return us mask. Otherwise, it will return us no mask label when it works in real time. And the next cell, I'm gonna talk about our training parameters. For this one, we have we have 3 variables that will access to specific address in our dataset. For example, train data dir is will get the address of the image dataset that we use for training. As I just showed you above section, our image dataset contains 3 folder. One is for training, one is for validation, one is for testing. And the second for validation data directory, and third is testing data directory. And we also assign the model save pass some location. For example, when we save our model in the last section, it will go this location. And now I'm gonna talk about batch size and number of epochs that we use for training our model. The batch size is can be like from 16 or 32 or 46. We can choose any of these according to our dataset. For example, our dataset is don't has many images. That's why I choose a 16. For example, if you choose a 64, it may create some problems sometimes, like memory out of error. That's why to get this kind of errors, I just choose page size 16, and I choose a number of epochs 20. Number of epochs means like when we loop our dataset, when we train our dataset, how many times it will loop and train and get the return result, and with which kind of validation or which kind of accuracy. And then next cell will be about the loading training data. For this we create the toList, train image pass, train label pass, and we access with this code we access to our directory. folder name in os ls train tier, and we loop it. If we have this directory, it will loop the files, and if the files, that means if our images ends with png, that means it will read the png format according to our code. But we can also use we can change like little bit. We can change like or to read the JPEG files also. We can change like file name dot and ends with, and inside this one we can write dot gpg, and we can copy this part of code, and we can also apply this code for our validation data and testing data. This code is for validation data. This code, both of code is the same, but I just write it separately for each of these to make it understandable for you. And we'll apply the same code for this one. Save. And for this one also we apply the same code. This code is for loading test data. All of the codes on the above and the below is nearly the same, except the except variable names. These two variable name and these two variable names. In my this cell, I'm just calling my face mask dataset class, and inside this I'm just using the train image path, train labels, and I'm just transforming this image to the matrices by using transforms.tensor. I'm also applying this for validation data and testing data. As you can see, the codes are the same, only the image paths and the labels are changing. And now I'm just download this above. After it's applied, I will download this data by using the data loader in PyTorch. And for this one, we're using the batch size. This batch size for this is a variable name that we that's equal to 16, because we on the above section we wrote batch size is 16. And shuffle is equal true. That means it will take the random images from different part of our folder and make it one batch, and another is making another batch to get the good performance in our deep learning model. For validation and testing, shuffle is false, because if it's order, we'll check what kind of validation we'll have. Like if our images are in order, we came the face mask model part, and we are creating the face mask model, and we are taking number of features from Torch NN module. If you remember, on the first line of code, we will import this code I want to write for you. Import torch.enn as enn. If you go to the first cell, this one, we import this. We use this code to get number of features from Torch library. And now there is no need to write, it can delete it. We are initializing this face mask model, and we are using for this one, we are taking the ResNet 50 pre-trained model, and through the num features we are giving some features, and we are making some changes, and and making it comfortable with our task. What I mean by this, we are changing this pre-trained model for our specific task to detect whether the person is wearing a mask or not. And here in this code, self.model.fc is equal to nn.linear and num-features and 2. That means in the output of our neural network, it will return two two output. One is for the with mask, one is for the person without mask. And after this process, I create the function def.forward and it will return self.model x. That means our x value passes through our model and it will return this x value after changes. That means this is the first step in a big propagation. This is the forward part of our big propagation. And after this, we called our model. We initialized to the model variable. In my this cell, I'm using the cross entropy loss loss function. We use this for multi-class classification problems. Like, for example, in our case, we are using it to detect whether the person is wearing a mask or not. And for the optimizer, I just use a optim.adam. I just use a adam optimizer. That will and I put the value for the learning rate 0.001. Each time our weights updates, and it will give a new value, and it will change by this learning rate. And for this code will be about like putting the steps for our learning rate. Each time after the learning rate changes, our learning rate can be decreased by this value. Gamma is equal to 0.1. And after we finish this process, we'll we'll move our this face mask model to device. In our case, whether it's GPU or CPU. And after this process, we'll begin train our model. As you remember, in the previous codes, we put the epochs and we put the number of epochs to 20. And now we are looping these epochs for epoch in range num epochs. In our case, this would be to 20. Num epochs 20, because we give the value already in the above code cell. And we start the model.train, and we are putting the running loss value and correctness of our prediction and total prediction, and to make it 0 for now. And after time it will increase it will increase, and we know like how many correct predictions we get, how many total prediction, what is the running loss. And after this process, we we loop our images and labels from our train loader, which is like a data loader that we that we initialized on the above. And it's moving both labels and images to our GPU or the CPU according to the situation. And after that, we use optimizer dot zero grade. Each time when it's when it's putting and changing weights, we make it 0. Otherwise, it will add for example, it will add the weights each. For example, first weights and the second weights, and the weights after this process, it will also add. That means it will result in crash. That's why each time our optimizer will make the gradient 0. And after that, we create the variable outputs and is equal to model, and inside is the variable images that we looped from train loader. That means this is predicting our images, because we are giving them, this is a model, it's a face model, and we are it's predicting. This is a prediction part of our code, and after that it's put the loss, it's put the loss function, and it will tell us this will tell us like our actual output and what is actual level and our predicted output. It will compare, and after that we are doing the backward part of our backward propagation by using loss.backward, and we use this optimizer.step to update gradients after each time we use this optimizer.step, and after this we are getting the maximal prediction probabilities from our output, and each time it's adding like total it's like adding total how many number of prediction we have, how many are correct from this code, and how many running loss. And in this code, train accuracy is equal to correct divide total. This is our train accuracy. We will found this by using the correct predictions is divide the total predictions. We know how many in fraction, how many values, how many percentage or proportion we get our accuracy is. And train loss is we are finding train loss that's equal to all of the running loss and divide to the length of train loader. That means we are finding average train loss here. In the next part, I'm going to explain about model evaluation on our validation dataset. As you mentioned above, we also have another folder. This is for validation purpose, and in this folder we also this folder is also contains some images of the person with mask or without mask, and we begin model.eval and begin evaluation. We also checking the loss and checking how many correct prediction, how many total for our validation. We are also creating another variable for our validation data, and with torch.nograd we are beginning, and we are looping the images and labels from validation loader, validation data loader, and it's repeating the same process. And on above this one, for example, if you back above, this is the same process. This process are the same, but it's all but we done this process for training our model. Now we are repeating this process with another variables for validation purpose, and we print the number of epochs, and we are printing our train loss and train accuracy and validation loss and validation accuracy by using this formula. That means when we divide on the above, we get the values, and after that we have to, in order to find the percentage of train accuracy or validation accuracy, we are multiplying it 100. And now I'm gonna show you my validation and train loss. It all looped over 20 times in our training when we're training model, and in the training loss is equal to, first time it was equal to 0.1442, training accuracy was more than 91, and validation accuracy is 100. In epochs 2 is changing, validation accuracy is lowering because it's updating the weights and bias each time in each epoch in our neural network. And totally we get in 20s we get a validation accuracy 100% and train accuracy 100% with train loss 0 and validation loss is 0.0003. That's good accuracy actually. And after this process we use this code to save our trained model. Torch.save model.static, and we give our model save path variable that we assigned the specific address where we will save our model on the above section. And we also did model evaluation based on our test data. In the above, as you can see, we just do this process for evaluating our validation data, but only variables is changed. The process is the same. And we are doing this process for the evaluation on our test data. We also save one more time after checking our the accuracy, how many to check the test accuracy, and we also save our model. Otherwise, we'll change from we'll go back part of our code until we get good accuracy. And I saved my model model one more time, and for this, printing the percentage of test accuracy and test loss. And test loss, that's good value. Our loss is 0. That means accuracy is good, and it's also returning 100% accuracy. And after that, I just download my model on Google Colab because for this project I used Google Colab for deep learning part. And next we move to next section. I will not give some brief introduction, but I will not play this code. You can learn by yourself. This is like a checking our model by uploading pictures. For example, you can upload the pictures of the person, and it will tell like face mask detect with probability 50 more than 51%, and it will tell no face mask with probability something to give some of the percentage. This is like for checking and seeing and upload by uploading image, but our project is all about real-time face mask detector. That's why it should detect our face on real time and it should tell us whether we are wearing a mask or not. This is the end of my first code. You can learn until this part. This part is enough. This is for optional. If you can check, you can learn by this, but our project is real-time face mask detector. That's why we will move second part. For my second part of my code, I use a Jupyter notebook. And now, as you can see, here I import the necessary library. Even I import the MTCNN model in order to detect my face. As I told you before, first my project detects the face of the person, and after that it crops, and it put the cropped image to my trained deep learning model that I create in the first part of code. Here is we are downloading our model that I wrote in the first part of code as a file, and I'm just using this code Torch.device CPU because on my laptop, on my device, I don't have any GPU. That's why I'm using my own CPU for running this code. And we copied this code from my first code, just calling and initializing this face mask detection model. And after this process, it's loading the static it's loading this model directory, and after that it's evaluating. In another project, in another process of this code, it's like making transformation for image, because it's making the image ready for my deep learning model by using this code. In this code, for it's resizing image and making height and widths 224, and then it's converting my image to tensor matrices, because our device cannot work with images, they can only work with numbers. And after this process, it's normalizing my matrices, as you can see from this code line. Transforms.normalize. I create this list to make a to write a labels, and in my case the labels is to it will show us after it detects the person's face. It will show us whether the person is wearing a mask or not, and it will show us without mask or with mask. And I just assigned the MTCN, our imported MTCNN package, to the detector variable. And after that, I will initialize the video capture. And if I wrote a code, like for example, if our camera is not open, it will print a message like failed to open the camera, and it will exit. From this, it will loop our frames from our video stream, and we if it's while true, read and frame is equal to capture.read. It will read our camera. If there is no read, it will print a message like failed to capture frame, and after that it will break. That means it will stop. And I create the RGB frame, and I just in order to convert the color of our frame from BGR to RGB. As I just said, the OpenCV uses a BGR, but in normal image will be in RGB color. That's why we convert this to RGB format. And after that, it will do face detection using MTCNN model. We assign the MTCNN model to the detector variable on the above, and from this detector we just call the detect face, and we just put our RGB frame here, and it will detect our faces, for example. And we loop this in this code. We loop the detect faces from the above, and it will crop the face region from the frame through this code. It will crop our only the image with face part of our image, and after that it will convert to PIL image format, and it will make a transformation by using code, because we wrote this transform function on the above. Let's go back above. This is a function, and we we use this for our this code, and in this line of code we add a batch dimension for the face image, and we call this assigned variable to here, and we use the unsqueeze in order to add a batch dimension for our face image. And in this code, we use the output is equal to model. That means it will predict, and here in the second part, it will find the maximum prediction, whether our deep learning model is predicting the people with mask or the person without mask, or people without mask, depends on image, and it will return us maximal probability, and it will predict the item. This code is returns 0 or 1 according to our deep learning model. From the two output layer, it will return 0 or 1, and if it's returned 0, we use the indexing here, list indexing, and it will return this label without mask. If it's return 1, it's in index 1 of this label is with mask, and after that it will draw a bounding box for the face, and write a label according to if it detects the face mask with higher probability. It will write a face with mask. If if it detects the person without mask, it will write without mask. And after that, I just show image show. And I wrote this code. For example, if you want to stop our camera, we will use Ctrl+Q and it will stop. Now let's run our code, and if we wait a little bit time, it will access our camera and it will use our model to detect whether I'm wearing mask or not. It start to running. Now I have to share another window to access my because another window pop up, so that's why I have to share my window and choose another. As you can see, it's detecting me without mask, and the camera works slow. I don't know reason why it's working slow, but let's wear mask and how it will detect. As you can see, it's detecting my face with mask. Now I will take out my mask. Oh, this is detecting correctly. If you enjoyed this video, please subscribe my channel and put the like button. See you on another videos.